This is a loglinear analysis. It deals with more than two categorical variables. So in this example, we have the animal type, either cat or dog, by the training type, either affection or food, which is the reward, and by the outcome, whether or not the animal danced as it was trained to do. So the first step in a loglinear analysis is to create a contingency table. So the general code for that is postable, but here's my simple code, and that assumes that we loaded in cats and dogs. So let's just do that and see. So I did that right. There we go. So cats and dogs is loaded in. Great. Now, in looking at this, we are looking at the dance, no dance. If I wanted to, I could make a different table that had a different variable in. So I'm going to call this table T2 just for ease. And I'm going to put dance here and animal here. Okay. So now we can kind of compare relatively easily cats to dogs. So for the cats who danced, we can kind of read across and say, all right, what type of rewards did they get? And how did it work out? So those who got affection as a reward, 114 of them didn't dance and 48 did. Okay? Whereas those that got food as a reward, 28 danced and 10 did not dance. That makes food as a reward much more effective for cats. In contrast, for dogs, 29 of those that got affection danced as compared to 7 that didn't, or 20 of them that got food as a reward did as compared to 14 that didn't. So we can from that kind of conclude that dogs are more inclined to dance probably in general, and that dogs respond to affection more than cats do. Cats appear to respond to food more than dogs do. But we don't know if that's significant yet. We can't really know about significance exactly. But we are going to test the model and remove some pieces. So now that we've made that, we have a contingency table, we're going to create a saturated model. So the saturated model is all of the combinations. It's animal, by training, by dance. That's a lot of combinations. We're going to then remove the three-way interaction. So I name this three-way because I'm removing minus the three-way interaction. I can now compare these two with an ANOVA command. So I can say saturated by three-way and come up with a very significant value, which means that those models are different. Because those models are different, the thing we removed mattered. The thing we removed was the three-way interaction. So we can say there's a three-way interaction between the animal type, what type of training received, and whether or not it danced. That gives us some reason to argue what I just said in the beginning, which was the differences between how the training works for the different animals. Alrighty, that is how that would work. The end.